Okay, so far I have just told you that you have numbers. Okay, let's quickly go through all of these concepts. Numbers can be real numbers that you can plot on number lines. Number line is a line in which you can plot all natural numbers which are 1, 2, 3. You can also plot 0, that means 0, 1, 2, 3, 4, all you can plot. That means you can even plot natural number that goes from 1 to infinite. You can plot whole number that goes from 0 to infinite. You can even plot negative values. That means you can plot integer as well. And not only this, you can even plot 0.5, you can even plot 1.5. That means you can plot rational number as well. In fact, you can plot all irrational as well. Root 2 can be plotted there. That means all these rational and irrational holistically, are broadly we can say all rational irrational together give you real number, because under rational we take those numbers that are in the form of p by q, where q is not 0 and pq are integer. And under this rational number we will already include natural, whole, integer, and under natural we already include even, odd, prime, composite. Now I will tell you quickly that what are these even, odd. I think you are okay that even are those that are divisible by 2. Divisible by 2, generally we take them as 2, 2, 4, 6, 8, they all are your even. They are generally positive. Odd are those that are not divisible by 2, and they are these. Yes, exactly, they are odd numbers. Then you have prime. Prime are those which are having exactly 2 factors, and composite have more than 2 factors. You just remember this thing. Exactly 2 factors. 2 has exactly 2 factors. 2 can be divisible by 1, 2 can be divisible by 2. It has exactly 2 factor. 2 has exactly 2 factor. That is why 2 is a prime. 3 is a prime. 5 is a prime. 7 is a prime. 8, 9, 10, they are not prime. Why 9 is not prime? Because 9 is divisible by 1, 9 is divisible by 9, and other than these two, 9 is divisible by 3 as well. It has more than 2 factors, and that's why 9 will be considered in composite, whereas the 11 will be prime. You don't worry, I will help you collect all primes. I will help you collect all composite as well. Okay, let's collect all prime and all composite, you don't worry. But before that, tell me what are composite. Number which has more than 2 factors. Or you can say number greater than 2 which are not prime. Like greater than 2 which are not prime is 4, 6, 8, 9, 10, and even many other. I have already...
Numbers are numbers with more than two factors, right?
Yes, more than 2 factors. One definition is more than 2 factors. Another definition is number greater than 2 which are not prime are composite. And after that there is a word square number. Square numbers also come under your natural number, and square numbers, if you take a square of 1 you will get a square number. If you will take a square of 2 you will get a square number. If you divide 3 with if you multiply 3 with 3 you will get 9, that is a square number. If you multiply 4 with 4 number, if you multiply number with the number itself you will get a number, that is a square number. If you multiply 5 with 5 you will get a square number. Even I have given you entire list of initial 20 square number, if you remember. All these are square numbers. See here on your screen you can see these square number 1, 2, 3, 4, 5, 6. You take a square root, then you get 1, 2, 3, 4, 5, 6. Without square root you are getting this. See, without square root you are getting this. These are your square number 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and all of these as well, like 121, 144, 169, 196, 225, 256, 289, 324, 361, 400. All these are square number.
Okay.
All these are square number. In fact, you can see this table here that include natural numbers, odd numbers, even numbers, integers, prime, square number, fraction, decimal. They all form the rational. And broadly, I've already told you that your number will form two type of numbers, that is real and non-real. Real can be plotted on number line, and real can be broadly categorized as rational and irrational. Rational is written as P by Q, whereas irrational can't be written as P over Q. And other than this, non-real are those that include negative value in the square root. If negative value comes in a square root, inside a square root, you will call those numbers to be non-real or imaginary. And we will deal with these numbers in detail later on in higher classes. For now, you are confined with the real numbers and the study of real numbers. But in real number, there are a lot of things to study. We can study a lot of things here in real number. Okay. What you can conclude for real number now? The first thing is real numbers can be plotted on number line. Second thing is real numbers broadly include rational and irrational. Rational can be written as P by Q, where Q is not 0 and PQ are integer, and irrational can't be written as P by Q. Do you know the decimal form of these? Okay, one more thing to cover here is, if you add rational with irrational, or subtract rational with irrational, or multiply rational with irrational, or divide one rational with another irrational, in all these cases you will get irrational. That is why 3 plus root 2, 3 minus root 2, 3 into root 2, 3 divided by root 2, and even root 2 by 3, they all are irrational. And not only this, even if you operate one irrational with irrational, another irrational, with plus, minus, or multiply or divide, you will get irrational only in all these cases. And that is why root 3 plus root 2 is irrational, root 3 minus root 2 is irrational, root 3 into root 2 is irrational, and root 3 over root 2 is irrational. But one more thing is here. You even ask that question, if I add two same irrational, if I subtract two same irrational, if I multiply two same irrational, if I divide two same irrational, what am I going to get in all these cases? What am I going to get in all these cases? The answer to this is, let's go with some question and then decide. Like if I'm if I'm adding root 2 with root 2, what will you get?
Okay.
You will get 2 times root 2. Now this is the case, rational multiplied with irrational. What you get if you multiply rational with irrational? Yeah, tell me, what you get if you multiply rational with irrational?
It will be like this.
Rational with irrational, what will you get? If you multiply rational with irrational, you can see, Rayan, here you can see. If I am multiplying rational, here, see, if I am multiplying rational with irrational, I will get irrational, isn't it?
Oh, it's irrational.
Yeah, that's why it is irrational. That means even if you are adding to same irrational, you will get irrational. But if you are subtracting two same irrational, like if you are subtracting root 2 with root 2, what you will get if you subtract two same quantity?
It will be 0.
It will be 0. And do you think 0 is rational or irrational? What do you think?
It's
Think and then tell. What do you think about 0? Can you write 0 as 0 P by Q, where Q is not 0 and P and Q are integer? Can you write 0 as P by Q? Yes, we can. 0 by 1, where Q is not 0 and 0 and 1 both are integer. And since it is following your definition of rational, it is rational. That means here you will get rational. What about this?
Actually,
Yeah.
actually, 0 shouldn't be in the denominator, right?
Yes, 0 should not be in denominator. In numerator, 0 can be there. Can you tell me what will you get if you multiply two irrationals?
Two irrationals.
Yeah, if you multiply root 2 with root 2, what will you get?
You'll get an irrational number only. It's root 2.
You will not get root 2. If you multiply root 2 with root 2, you will get root 2 into 2. That will be one pair is there. Yeah, one pair is there. You will get 2 as answer. What do you think about 2? Is it rational or irrational?
It's rational.
It's rational, exactly. Well done, that's good. It's rational. You will get rational if you multiply two irrational. And what about this last scenario? Can you tell me what will you get if you divide root 2 with root 2 itself? What will you get in this case?
If I divide, so it will be
Root 2 over root 2. What will you get if you divide root 2 with root 2?
root 2 divided by root 2. So
Yes.
if I have to do root 2 divided by root 2, it will be 2 only.
What will you get if you divide 4 with 4?
If I divide 4 and 4, right?
Yeah.
It will be 1.
It will be 1. Then what? Then why? How will you get 2 if you divide root 2 with root 2? It is equivalent to root 2 over 2. And that is equivalent to root 1. And root 1 is 1. Actually, if you divide two same quantity, you will get 1.
Oh, okay, okay.
What do you think about 1 now? Is it rational or irrational?
Rational.
It's rational. Well done. Okay, now you can note down all these concepts that you have not written it. These are another concept. In this concept, if you are adding two same irrational, then only you get irrational. In all other cases, subtraction, multiplication and division, you will get rational. And what about this? If you are adding two different rational, or if you are subtracting or multiplying or dividing, or if you are adding to same rational or subtracting to same rational or multiplying to same rational or dividing to same rational, in all this scenario you will get rational only. You can consider example yourself. In all these cases you will get rational only. Like you can take 2 and 3 as an example. Then 2 plus 3 will be 5, that will be rational. 2 minus 3 will be minus 1, that will be rational. 2 into 3 will be 6, that will be rational. 2 over 3 is rational. 2 plus 2, 4 is rational. 2 minus 2, 0 is rational. 2 into 2, 4 is rational. 2 over 2, 1 is rational. In this way you can decide whether it is rational or irrational by taking some example. And I have concluded and I have presented all important and all possible cases here. Note down them all quickly, and then I'm explaining one more thing with a very interesting diagram. Once you note it down, let me know that. I think it's very easy for you to note down. I think you have almost written everything. Note down these two more concepts that you have not written, I think, and then I will explain you the next concept, and I will draw the diagram now. I will draw a very interesting diagram now. If you have written it, come towards left. I am drawing a very interesting diagram here. Meanwhile, you write down everything, and I am trying to draw a very interesting diagram here. and that diagram I think will be very much helpful for you. In this diagram you will just observe that I have drawn a very interesting rectangle where I'm indicating that I'm telling it is a number system. Then in this number system we have two type of numbers. What are those two type of number in your number system? These can be,
Is this a Venn diagram?
yes, it is a Venn diagram. Well done, you know that. It's a Venn diagram. In this Venn diagram, I'm going to tell you about two type of numbers. One is, actually in number system we have two type of numbers: real numbers, capital R, and non-real numbers.
I'm just noting down whatever you mark. So
Yeah, now you start writing this Venn diagram. This Venn diagram will help you understand many basic things. Now under real numbers, you have first type of numbers that are natural number.
okay,
And natural numbers are, all natural numbers are included inside your whole number. That's why now I will draw a big circle that will include all kind of natural number. Actually whole number is that circle, and all whole numbers are already included inside your integer. That's why integer will cover all those natural and whole as well. And there is one more diagram I'm drawing here, one more circle I'm drawing here, that is going to be your this circle. Do you know what it tells? It tells about your rational number. And there is one more thing that you can draw, which can be drawn like this, and it includes irrational number. And that is why broadly I say these rational, irrational together give you all real numbers. And now there is one more interesting thing here, and you will be very much amazed to know this. This particular analysis is going to help you frame many statements. You can frame many statements. Like, listen, if you are moving from bottom towards top, you will say yes to your statement.
okay,
Real. All irrational are real.
okay.
Do you think it is yes or no?
Yes, it is.
I'm writing it here. All irrational are real. Then what do you think if I write all natural are whole? Is it true?
Yeah, natural numbers are whole numbers.
It's true. Do you think all natural are integer?
Yes.
Yes. Do you think all natural are rational? And do you think all natural are real?
Natural numbers are rational numbers as well. So it's true.
And do you think all whole number are integer? all whole numbers are rational, all whole numbers are real, what will you put in these statements? Tell me quickly. And what do you think all integer are rational? What do you think if I write all integers are real? These are 10 statements in front of you and they all are correct, because in all these statements you are moving from bottom to top.
Yeah, from bottom to top.
Yeah, all rational are real.
Moving from bottom to top.
All rational are real.
Okay.
Okay. All non-real are number system, all real are number system. This is also true. But if I move from top to bottom, anyway, if you move from top to bottom, the answer will be no. Do remember that as well. Like if I say all whole are natural,
No, they're not.
it's not true. All natural are not whole.
They're not whole numbers. Natural.
Actually, zero is there that you can't include. That's why all natural are not whole. Do you think all rational are integer?
No, I think.
No, because you are moving again from top to bottom. Do you think all rational are natural?
No.
No, they are not. In this way, this Venn diagram is going to help you a lot while you are framing these in true and false basis. You can answer them very quickly if you understand this concept, that if you move from bottom to top, you are getting yes in your statement, and if you are moving from top to bottom, you are going to say it's no. Like if I say all real are irrational, what will you say? Yes or no?
No.
It's no. But the opposite is true. If I say all irrational are real, then it is true. But if I say all real are irrational, then it is false. Not true, false.
It is the opposite. It's
Yeah.
exactly the opposite.
Yes. I think you must be okay with all these explanations. Let me know if any difficulty anywhere up to this.
Okay.
Yeah. After that, there are some other numbers as well that we can discuss in our discussion, that can be in our discussion. Like there is one number called cube number. If you take the cube of 1, you get 1. If you take cube of 2, you get 8. If you take cube of 3, it's 27. If you take cube of 4, 4 cube is 4 to the power 3. That means 4 times 4 times 4, which is 64. 5 cube is 125. 6 cube is how much?
6 cube is 6 times 6 times 6.
216.
It's 2 and 6. Yeah.
And 7 cube is 343. 8 cube is 512. 9 cube is 729. And 10 cube is 1000. All these are your cube number. Then there is one more word. I'm not saying perfect square. I'm only saying perfect number. There is difference in perfect square and perfect number. A square number has another name, perfect square number. A square number has another name, perfect square number. But it is but perfect number is other than this perfect square. If word is used perfect square, then you can call them square number. But if I'm saying only perfect number, then perfect number is other than your perfect square. Then what they are? What is the perfect number? Do you know what is perfect number? Like if I ask you to find the factors of 6, what are different factors of 6? First tell me you that. 6 is divisible by 1.
Yes, 6 ones are 6.
6 is divisible by 2.
Yeah.
6 is divisible by 3.
Yeah, it's 3 twos are here.
6 is divisible by 6 as well.
Yes, 6 ones are 6.
If you add all the factors of a perfect number, you will get twice of the number.
Okay. I understand that.
And there are some perfect number that I want you to remember. Actually, it is very tedious task to find out all the factors and add them. 6 is a smaller number, that's why it is easy for 6. That's why I will ask you to remember initial 4 perfect number. 6, 28, 496 and 8128 are some perfect numbers. All between them are not perfect, do remember. After 6, 28 is perfect number, and after 28, 496 is perfect number, and after 496, 8128 is perfect number. And after this discussion, there is one more word called co-prime numbers. This co-prime word is not used for single number. Co-prime numbers are two numbers. Any two numbers whose HCF is 1 are co-prime. Like if I take the HCF of, if I ask you to find out HCF of 2 and 3, what it will be? Obviously 1, because 2 and 3 both have common factor 1. Do you know, it is not always true that they both are prime. Even if first is 2, another can be even as well. In this case, another can't be even with 2 because both will have the factor 2 then. But if you take 3 as your first number, the second number can be even as well. Like second number can be 16. Second number can be 4. The main scenario is their HCF should be 1. If two numbers have their HCF 1 or they have a common factor 1, then you call them co-prime numbers. What do you call to them? Co-prime numbers. And after this much discussion, there is one more thing that is called fundamental theorem of arithmetic.
Fundamental theorem of arithmetic.
Yes. This fundamental theorem of arithmetic tell you about prime and composite. Actually, fundamental theorem of arithmetic says every composite can be written as unique prime.
Unique prime.
Yes, every composite can be written as unique primes. Like if I ask you to write 6, you can write 6 as the product of prime 2 and 3. You can You can change their order if you want, but can you change these prime? Can you take 5 with something to get 6? You can't. That is why they are unique.
That's why they're unique prime numbers.
Yeah, not only this, we can take any number. Like if I ask you to write 4096, it is a composite as a product of prime, you can do that. You know the method to factorize it.
Oh, okay.
You can go with this factorization approach. Let's do it. 2 2s are 4, 2 5s are 10, 2 6s are 12, 2 1s are 2, 2 2s are 4, 2 8s are 6.